All right, guys, so what we're going to be looking at here is a question from the 2014 exam where we've got a couple of different ideas. This is mainly a graphical analysis question, but there are a couple different ideas that get worked in here as well. So let's go ahead and jump in and take a look at this one, okay? So we've got the twice differential functions f and g are defined for real numbers. We've got values of f prime, g, and g prime are given in the table above. Now you'll notice in all of these columns, it tells us negatives and positives for the function, for the derivative of each of those. It's almost like they've made a number line for us, that number line that we make when we're doing graphical analysis. So they made it for us, and they've shown us like the first derivative is equal to 0 there and there, the second derivative is equal to 0 there. Those will come into play, and it gives us other value as well. So just know that all those are, that's going to be important when we start looking at this, okay? So we've got, it says find the x-coordinate of each relative minimum on the interval from -2 to 3. Well, in order for us to have a relative minimum, two things have to be true. First of all, we need to have a critical point, okay? So remember, a critical point is where the first derivative is equal to 0. So there and there are my critical points at x equals -1 and 1. And it also needs to change, the first derivative for f needs to change from negative to positive. We need to go from decreasing to increasing. That happens at x equals +1. At x equals -1, it goes negative, negative. So it's almost like it decreases, then it levels off, then it decreases some more. But at x equals +1 right there, we have ourselves some sort of relative minimum. So that is the correct answer for letter A. Letter B, explain why there must be a value of c such that the second derivative is equal to 0. Now, if it gave us the second derivative, we could use the intermediate value theorem, or at least try to use the intermediate value theorem, but it doesn't. It only gives us the first derivative values between -1 and 1. So if we're trying to show that the derivative of what we have is going to be equal to 0 somewhere, what we do is we just find we plug in the 2 points into the function that we would take the derivative of and see if that's the slope that we get so that we can use the mean value theorem. So in this case, I get 0 over 0, 0 minus 0 over -1 minus 1, which gives us 0. So indeed, because this function is differentiable, we can use the mean value theorem, and we got that average rate of change. So that means that, yes, there must be a value. Like we just show that there must be a value so that the second derivative is equal to 0. The third one says, let h be defined by h of x equals the ln of f of x. Find h prime of 3. Well, in order to find that, it wants us to take the derivative first. So the way that I take the derivative of the ln of something is 1 over that something multiplied by the derivative of that something. So there's my derivative. Now I need to plug in 3. So I've got 3 plugged in both of those places. F of 3, I can see on the graph, is 7, so I've got 1/7 multiplied by f prime of 3 is 1/2. So if you simplified that down, you'd get 1/14. You don't have to. This answer is totally fine for letter C. Letter D, this one's tricky because it wants us to evaluate from -2 to 3 of f prime of g of x times g prime of x. Well, that looks really weird, and what you have to understand on this one is there's no way to take the antiderivative, and the only way that we know how to take the antiderivative of complicated things is by using u substitution. So I'm going to let u equal g of x, which means du dx is equal to g prime of x, which means we've got du over g prime of x is equal to dx. So I've got the integral from -2 to 3, and we're not done with that yet, but I've got f prime of u times g prime of x multiplied by du over g prime of x, which helps us a lot because we wanted those to cancel out. Now we also need to change these values to u values. So when I take g of 3, I can see that g of 3 is 1, and I can see that g of -2 is -1. So really this is the integral from -1 to 1 of f prime of u du. Now all I have to do is take the antiderivative, so I get f of u, and I evaluate that from -1 to 1. So I plug in 1, f of 1 minus f of -1. F of 1 in this case, we can see f of 1 is 2, f of -1 is 8. So 2 minus 8 is -6, and that is the correct answer for letter D. Again, that one's kind of tricky just because you had to use u substitution, but hopefully you can see how we got that on that problem. Anyway, if you have any questions on this or any other ones, please let me know.